is going to introduce the modulus function, which is denoted by these two vertical lines, which you should hopefully remember from your work on vectors, also means the magnitude or size of a vector. And it has a very similar meaning here. It means the magnitude or size of a function. So what it does is it returns the positive value of the function. It doesn't care whether it's negative or positive, it's just the size, the numerical value of the function. That's what the modulus does. So the modulus of -4 is just 4. We don't care about the fact it's negative. We just say the modulus of -4 is 4. So what the modulus function is doing in that case is it's multiplying that -4 by -1 to turn it positive. The modulus of 5, well, that's just going to be 5 because 5 is already positive, so the modulus function doesn't do anything to that. The modulus of 5 is just 5. So let's have a look at drawing the modulus function graph. We're going to do it in a couple of different ways. First of all, with a table of values. The graph we're going to draw is this thing. Y equals the modulus of x minus 2 minus 1. So the order which we're going to do things here, we're going to substitute x values in here. We're then going to subtract 2 from that. Take the modulus of it to make sure that it's positive. And then at the end, we'll subtract 1. And that will give us our y values. So first, we're going to substitute -3 in. So when x is -3, we have -3 minus 2 is -5. The modulus of -5 is +5. Minus the 1 is 4. Next, we're going to substitute -2 in. -2 minus 2 is -4. The modulus of -4 is +4. Subtract the 1 is 3. Next, we're going to substitute -1 in. -1 minus 2 is -3. The modulus of -3 is +3. Subtract the 1 is 2. Next, 0. 0 minus 2 is -2. The modulus of -2 is +2. Subtract the 1 is 1. Next, substitute the 1 in. 1 minus 2 is -1. The modulus of -1 is +1. Subtract the 1 is 0. So just notice at this point that all of these values here, the modulus changed the sign for. Continuing, when x is 2, we have 2 minus 2, which is 0. The modulus of 0 is 0. Minus 1 is -1. Next, 3 minus 2 is 1. The modulus of 1 will still be 1. Take away the 1 is 0. And then we have 4 minus 2 is 2. The modulus of 2 is 2. Take away 1 is 1. So notice for these values here, the modulus didn't do anything in those cases. Right, let's plot these points. We've got the minus 3, 4, which is roughly up here. We've got 2, minus 2, 3, which is here. Minus 1, 2, 0, 1, 1, 0. 2 minus 1, 3, 0, and 4, 1. And I'm now going to join those points up. Like so. And notice that this graph is made out of two different straight lines. We've got this straight line here where the modulus changed all those values to be to be positive. And then we've got this part of the graph here where the modulus didn't do anything. And so what we can do is we can think of this graph as being two different simple straight lines joined together. The green part of this graph was where the modulus didn't do anything. So that's just x minus 2 minus 1, which is x minus 3. So it has a positive gradient. We can see here it's got a positive gradient of 1. It's got a negative y-intercept of 3 there, because if I did continue this line, it would intersect at minus 3. The yellow part of the graph, that was where the modulus did change the signs. It changed all of this. It changed the x to be a minus x, and it changed the minus 2 to be a plus 2. So the yellow part of this graph is y equals minus x plus 2 minus 1. Or just y equals minus x plus 1. It has a y-intercept of 1, and it has a negative gradient. So sometimes it can be very useful, especially when we're solving equations in the next video, to think of the modulus graph, to think of this as its two separate equations. This where we have a negative gradient, and this where we have a positive gradient. So that's a key concept here, the fact that we have two different equations on the graph. As always, when we are drawing a graph, we need to make sure we're including key coordinates. We have the y-intercept, which is when x is 0. In this case, that's when y is 1. We have the x-intercepts, which is when y is 0. In this case, that was when x is 1 and x is 3. And a new key coordinate that needs to be included with the modulus graph is something called a vertex. The vertex is the point here where the graph changes from the modulus having an effect where it doesn't have an effect. It's where we have the graph at its smallest value. At this point here, it's the 2 minus 1. We can read off the coordinate of the vertex from the equation. The x-coordinate of the vertex is going to be when this part of the equation equals 0. So when x minus 2 equals 0, which is when x is 2. The y-coordinate of the vertex then will be when this is 0, minus the 1 is minus 1. And that's the smallest that this can possibly be, because the modulus always returns a positive value. So the smallest it can possibly be is 0. It can't be smaller than 0. So that allows us to say something about the range of this function as well. Now, I can say that the y-coordinates of this function will always have to be bigger than or equal to minus 1, because minus 1 is the smallest this function can possibly be. Right, let's have a look at another way that we can sketch the modulus function. And we're going to do this with the idea of graph transformations. Because this time we're going to draw this graph. Y equals the modulus of 2x minus a minus b, where a and b are positive integers. So I couldn't do a table of values of this because I don't know what a and b are. So we're going to do this via graph transformations. I'm first going to think of the very simple just 2x minus a graph. That's what I'm going to draw first of all, because I know that's a straight line. It has a y-intercept of minus a. So let me put minus a roughly here. And I know it has a gradient of 2. So along 1 up 2. So it's going to look something like this. I can work out the coordinate of this point here because I know that's when y is 0. So if I put 0 here, add a to both sides, divide both sides by 2. So this point here is the coordinate a over 2. Right. I've drawn the most basic 2x minus a graph. I'm now going to apply the modulus function to that, which remember doesn't do anything where the graph is positive. My graph is positive here. So that part of my graph is going to be completely unaffected. That's going to stay exactly the same. So that's going to stay like that. But this part of the graph here, where it was negative before, the modulus is going to turn all of that positive by multiplying it by minus 1. So it's going to look something like that, where it now intercepts on the y-axis at positive a. So just to repeat, this is the regular part of the graph, the 2x minus a part of the graph, where the modulus had no effect. This part of the graph here, that's the bit of the graph where the modulus did multiply it by minus 1, it did affect it. And so I could say the equation of that yellow part of the graph is minus 2x plus a, because it's got a negative gradient and a positive y-intercept. Finally, the last bit of this graph transformation is dealing with this minus b on the end there. So I know what that's going to do. It's going to affect the y coordinates, because the b is on the outside of the function. And I'm going to subtract b from all of the y coordinates. So everything's going to shift down. This whole graph is going to shift down b units. So my vertex is going to move down. The x coordinate of my vertex is still going to be a over 2. That's not changing at all. The y coordinate of my vertex, or the y coordinate before, was 0. So my y coordinate now is going to be 0 minus b, which is minus b. And again, remember, we can work out the coordinate of that vertex just by looking at the equation of the graph. The x coordinate is when this bit here is 0. When is that bit there 0? So 2x minus a equals 0. So 2x equals a. So x is a over 2. So you can work out the x coordinate of the vertex from there. And the y coordinate of the vertex will be whatever's on the outside here, so minus b. So you can work out the coordinate of the vertex just by looking at the equation of the graph. Anyway, the red part of the graph that was unaffected by the modulus before, that's going up here like this. That's now got an equation. It had 2x minus a before, and we've just subtracted b from that. And then we had the yellow part of the graph that's going to be going up like this. That did have coordinate equation minus 2x plus a before, and we've just subtracted b from that. As always, let's make sure that we mark on the key coordinates. So the so the y-intercept here. Well, previously that had y-intercept of a. We've just subtracted b from that. So that's going to be a minus b. We can also tell that by looking at this part of the equation. The y-intercept of that yellow line is a minus b. Now, we do also want to mark on the x-intercepts here and here. To work out this one, that's where the yellow line has got y coordinate 0. So let's take the yellow equation and make the y coordinate 0. So if I add 2x to both sides and divide both sides by 2, I can say that that coordinate is a minus b over 2. That's one of my x-intercepts. The other x-intercept here is where the red line has got y coordinate 0. Add the a and the b to both sides, divide both sides by 2, and I find that that coordinate then is a plus b over 2. So there we go. I have, via a series of graph transformations, drawn the graph of y equals the modulus of 2x minus a minus b. I have marked on the y-intercept, the x-intercepts, and the vertex. I can say that the range of this function, the smallest y can possibly be, is minus b. So I can say that its range is that y is greater than or equal to minus b. And something that really helped me to do this question, and will be incredibly helpful in the next video as well, is thinking about the two different equations of the lines that are on the graph. One where the modulus multiplied the inside by -1, so change this to a minus, change the 2x to be a minus 2x, and change the a to be the minus a to be a positive a. And then the other part of the graph where the modulus had no effect, so it just stayed as a 2x minus a. So that's what the modulus function is, and how we can draw the graph of the modulus function in two different ways.